Hello friends, today I'm going to talk about Leetcode 124 binary tree maximum path sum. The problem is that given a non-empty binary tree, find the maximum path sum. And the path sum is defined as the path that can be go through from any node to another node along the parent and child connections. And we are going to find the maximum sum of all these paths. And there's a condition that the path at least has one node. And it doesn't need to go through the root. So here we can see that this is the answer for 213. This is the path that is we get the answer. The sum is 6. And here for this tree, we know that this is 15, 20, 7. This is a path. As long as it can go through the parent-child node, is continuous along the tree, so it's a valid path. And let's consider how to solve this problem. Because we are going to find the paths and then sum, so the naive solutions is that we can find find all the paths, and then we'll check the sum and get the maximum sum of all the paths. This is too trivial, and this is I think it's time consuming. And the second is we can optimize it to write this, use DFS, but I think in my mind, in this idea, it could also possibly traverse all the paths, but it doesn't explicitly traverse all the paths. But when do the just try to get and it removes lots of redundant visits of the nodes, so it can reduce the time complexity a lot. So, because this is obviously it has a small problem in this function here, for example, and we have this example. And if we know that 15, 20, and 7, this is already a sub-problem, we know it's a maximum sum for this sub-trees, and then we consider as a whole together, so the same as we consider 42, and then we consider this tree, whether we get the maximum path sum. So we can use the DFS idea to solve this problem. But how can we solve this? So we can consider let me consider some some special cases. For example, if 1, 2, 3, for these cases, we know the maximum sum is 2, 1, 3, right? And this shape, let me write in blue color, 2, 1, 3. So it's 2, 1, 1, and 3. And is actually it's the it's the left tree is the maximum sum we can get, plus the right tree sum, and plus the root, the values. And this is the first case. And when we consider the second case is that if here is -1, 2, and 3. And here so what is the answer for this here? And the maximum answer is 3 only, right? This is actually the same as this case, that is actually it's 0 and 0 here. So it's like the it's now this tree 3003, and then we consider this because this tree here 2 -1 3, when we add together is made mistake. This here is the answer is should be 4. Okay, not 3. This is the same. So then this case is not a good answer. And maybe let's consider -1 for this case. And for this case, we get that tree. This is the answer. This is the same as this subtree, as the same as this tree. We get 0 plus 0 3 0. And after that, we will continue to compare with this -2 and -1 to get the answer, because this -2 -1 is not is smaller than 3, and or this could be smaller, -1 3, or this is also smaller. So the whole example is 3. And so this is actually the special case of this one. So we also don't consider it a case. And the second case is let's have 1 -2 and -3 here. And for this, what is the answer here? The answer is only this root values is 1, right? So for these trees, we only consider it's at 1 node here. And also, the third case is that if we have 1 and -2 and 3, okay. And for this, what is the answer here? The maximum path sum now we know is 1 3, right? So it's 1 3. So here, why do we know is 1 3? Well, it's not like this one. It's all like not this or this. So actually, we have to compare with this, with the left one, and all the whole one. And for this cases, and we get the left or the right, and we get the maximum. The maximum and then plus root values. Let me use root to indicate the value here. So plus root. So this is the third case that we need to consider, and So basically, there are we can consider there are three types of case. One is the left plus right plus root, and the other is whether we choose left plus root or right plus root, or we only choose the root itself. But this is actually can be considered to whether do we need to consider it? This can be so for the consider this, we have to consider that whether if the subtree has negative values, so we do not need to consider subtree. For here is -2 and -3 because they are negative, so we will delete this subtree. So when we traverse, we can consider that it compare with 0. If the current written result is negative, we will return 0 for its subtree, and this is also return 0 for the subtree. So this is the way how we write the code here. And when we write the code, we also need to consider the return values for this. The return value should be the whether we go to left, whether we go to left and up again, or we go to way from the top and root and right and right and right again. So we have to return the left plus root and right or the right plus root. So we cannot return this as the return value of the subproblem. So let me write the code to explain more with this. So we can define a maximum value, maximum sum, initialize at the infinity, minimum infinity, and we will define a helper function here, a root. And first, we consider the base case. The base case is when the root is empty, we return 0. And then we consider the left. So here, because if left is negative 1, so we will return the 0. So we have get the max. And then we will try to call the max left function again, and similarly for the right. And we call the its right root. If right root is negative, we will get 0. Otherwise, we will return the right values. And then we update the maxsum, because the maxsum could be any of the other two cases. This for the case 1 and case 3 here. Actually, this case 2 is included for this max 0 here, 0 here, and then we consider the 1 and 3. So we get the root value plus left and root, or root value plus right, or root value plus left plus right, and then we return. So here is what should we return here, and we should return this one or this one, because we have to return this one, because it's like if 15, 20, and 7, we cannot return whole, and then try to continually to construct a bigger path with their parent node, right? So it's only 15, 20 can be constructed with its parent nodes to get a bigger path. We cannot use 15, 27 to construct a big path with the parent node. So we have to return maximum left and or right plus root raw value, and then we call this have a function root and returns after maximum sum. Okay, we made it. Thank you very much.